Hi, we're going to do a quick video on section 4.15, and this is really talking about a lot of things that we've already done, but it's looking at them in a different way. And we are going to be talking about the comparison of rational numbers. So remember, rational numbers encompass everything that we've been talking about. So they include negatives, they include fractions, and decimals. And often they're going to need us to move between those three ways of writing in order for us to understand what we're doing, and especially when we have to compare them. So the example that the book gives in this one is that Christine is looking to buy a piece of ribbon, and the only ribbon that she finds comes in 3 sizes, and she's trying to get the one that's the longest. One of the pieces of ribbons is 2/3 of a yard, one size is 7/8 of a yard, and one size is 0.8 of a yard. I could put a little YD for yard. And the question is, which of these is the longest? So just like normal, I'm going to make a number line to really look at what these things are and what they're doing. If I go 0, 1/2, and 1, and instead of a half, I might even want to put 0.5, because I find one of the best ways to compare decimals like this is to take my fractions and turn them into decimals, because a decimal is really nothing more than a fraction that's just out of 10, because I could say this is 8/10, but I want to know what all of these are relative to each other. So I'm going to just borrow my little calculator over here, and let's do a quick little decimal comparison. So if I have 2/3, it's going to give me 0.66 repeating, right? I have 7/8, 7/8 is 0.875, 0.875, and my 0.8 of a yard. All right, let's fill in the rest of this. I guess I don't even need this part. 6, 7, 8, 9. 0.6, 0.7, 0.8, 0.9. Okay, so we'll call this our number 1, our number 2, and our number 3. So we have our 0.66, which is about right here for our number 1, our 0.875, 0.875, about right there for our number 2, and for number 3 is going to be right here at 0.8. So I can see that I suspected that this 2/3 was going to be the smallest, but between 7/8 and 0.8, there's not an obvious answer. So here I can see that if I were to rank them from greatest to least, I could write 7/8. If I go greatest to least, I would do 7/8, 0.8, then 2/3. Now, I want to remember to relist them in the same style that I did in the beginning, because it might be relevant to the problem. So the best way to do these is to look at them on a number line. And a lot of these are going to be kind of tricky, because they're going to throw in decimals, fractions, and they're going to start to throw in some negative numbers. Let's take a look at one of these that includes these negatives, because you need to remember that whatever is farther to the right of the number line is bigger, and whatever farther to the left is smaller. Even when a number is bigger, negative, it actually means that it's smaller. It's a larger debt. Let's take a look at what I mean. I want to compare the following. Let's do example 1. Let me move some space so I don't run off and everyone gets mad at me. That's the worst. I'm going to compare negative 4/5 and negative 0.25. Now, the easiest way for me, again, is I want to take it into a decimal so I can start to look at them as a decimal. So I know 0.25 is like this. I'm just going to do my 4/5 is 0.8. So I have negative 0.8, basically, with a negative 0.25. Okay, so if I'm going to build my number line, I can see they're all between 0 and negative 1. Let's build my little number line again. Now, you don't have to build a number line, but if you're ever confused or you want to see and be sure, definitely build one to see. Okay, let's go with 0. Let's go with -1, because remember I'm going this direction. And I'm going to go with -0.5, -0.6, -0.7. Ooh, this is a time-consuming number line making. -0.9, -0.4, -0.3, -0.2, and -0.1. Ooh, okay. So -0.8 I've got right here, and -0.25 I've got right here. So the question is, remember this side is bigger, and this direction is smaller. If I'm going to include a sign in the middle of these two, I can see that 0.8 is smaller than 0.25 because it's farther along this direction on my number line. So if I'm going to write this, I would say that 0.25 is larger by putting this symbol in. And for this assignment, you're going to be putting in this symbol between the two numbers to figure out which is larger. That's going to be our big comparison. If you feel like you understand it and you remember all those ways to do it, then go ahead and try it out. I'm probably going to do 2 more examples if you would like to watch and if you're not quite sure what I'm doing. Example 2. All right, we're going to compare, oops, wrong color, -0.7 with -7/10. All right. So if I were to draw a number line, first let's put it into a decimal so I can see. I've got this is already in a decimal, and this is -0.7. Oh, well, this one's pretty easy because sure they're negative, I can definitely see that, but I know that these two are going to be equal because they're the same numbers that I had before. I'm going to do one more quick example. Let's take a look at this. We're going to compare 7.77 repeating with 7 and 7/10. So here again, I'm going to turn them both into decimals because that's the easiest way for me to see what's going on. This is already a decimal, and this one here is 7 and 7/10. I know what that is. That's 7.7. And when I compare numbers like this, I can go sequentially down my place value. So here it starts off with my 1s are the same, my 10ths are the same, and this number here I could say has a 0 here because I can always add zeros on the end. And I can see, well, this one has a 0 and this one has a 7. So that clearly means that this number here is larger, so that I'm good to go, and I've been able to compare these two numbers. I didn't need to use a number line in this case because I was able to see it pretty easily with doing this. Now if it was negative, of course, it would be opposite. Alright, that's pretty much it on this one, and good luck.